Hey everyone, welcome back to another video of Vic's Math Corner. Today, we're going to be going over like terms and how to combine them. First of all, the concept of like terms is actually described in the name itself. They simply refer to quantities that are the same, hence like terms. So before we get started, let's really dissect the parts of a term. So let's say we have the term 2x cubed. There are three things that can be extracted from this. So the first thing, which I boxed in blue, is known as the coefficient. The coefficient is in front of the variable and the exponents, and it kind of refers to how much, or like the number of values that there are. We're going to show a visual after this so you can really understand what that means. Next, what I'm circling in red is known as the variable. So the variable is what we covered in the last video, and it basically is a value that is not known immediately, but it represents some kind of amount. Lastly, what we have boxed in black is known as the exponent. The exponent is pretty much signals how many times the base should be multiplied by itself. So let's show this term 2x cubed visually. So first, if you hide the 2 and you just see x cubed, that's basically telling you to write out x multiplied by itself 3 times. So x times x times x. Now, since there are 2 of them, you can think of it as this. So x times x times x. And these values are being added to get 2x cubed. So let's move on to some more examples. Let's say we have x cubed and we're adding 5x cubed. So the first thing to identify for a problem with like terms is whether they're actually like terms in the first place. So in order to be like terms, they have to have the same variables and same exponents. So as you can see here, both involve x cubed. So both are x times x times x, just like in the last example. Let's say, for example, the one on the left was x cubed times y, so it would be x times y. These would not be like terms because they're not exactly the same. So now let's proceed with this problem. What you can do with these problems is add the coefficients. So you might see that on the left there's no coefficient written, but this really just means that there's 1 in front of it. There's 1 value of x cubed. On the right, we have 5 of this value. So if you add the coefficients, which I'm underlining, since the problem is asking you to add, you'll get 1 plus 5, or 6, and then you can transfer down whatever the variable and exponents are. So x cubed in this case. So if the problem were to be asking you x cubed plus 5x cubed, your answer would be 6x cubed. Now, alternatively, let's deal with another example. Let's say the problem is something like 2xy minus xy squared. So forget about the coefficients for now. This one on the left is xy, and this one is xy squared. So xy squared is really x times y times y. So if we have xy and x times y, these are not the same. So therefore, you cannot combine these terms. Now let's deal with a harder example, one that you'll probably see in your algebra journey. So given the problem x squared plus 3y plus 2xy plus 4x squared minus 5xy. It first looks a little daunting. There are 5 total terms in here, and simplification may seem a little tough at first. But what we can do is break this into easier steps. So the first thing is to identify the like terms. So you're going to look at which variables and exponents are the same. And for now, disregard the coefficients or the numbers in front. So we can identify that this term here that I'm underlining in red and the other one both have x squared, which is x times x. Now, there's only 2 of these terms, and that's why we have them underlined in red, but we can also find 2 terms that involve x times y, 2xy and negative 5xy. Lastly, there's one term left, and there's no other like term with it, right? There's only 3y here. So now we can simplify. So let's rewrite this with the colors that we assigned. X squared plus 4xy, plus 4x squared, now plus 3y, as we're taking this term that I'm boxing right here, plus 2xy, as we're taking the term that I'm boxing right now, and lastly, we're subtracting 5xy. So if you were to simplify, you would take the coefficient of 1 in front of the x squared plus 4x squared to get 5x squared. Then, since there's nothing to simplify with 3y, since it's the only term that involves just y, you can just drop this down and get 3y. And lastly, if you were to get, in this situation where we have 2xy minus 5xy, you can do 2 minus 5 to get negative 3xy. So hopefully you understand how to combine like terms. Algebra is full of these equations with different terms, and there's always a need to simplify these equations, or to make these equations similar and easier to deal with, like how we did in this problem. This is why this is a concept that's good to know early. As always, thanks for watching. See you in the next video covering linear equations. Always feel free to drop any comments or questions in the comment section. Thanks.